This is the third part of the 2004 Cayley test for the Waterloo math contests. And this is question 17. Question 17 says two whole numbers m and n satisfy m plus n equals 20 and 1 over m plus 1 over n equals 5 over 24. The product mn is equal to. So we don't really have to bother with m plus n equals 20 just yet. We can firstly simplify this. If we multiply the top and bottom by n for this, and we multiply m in the top and bottom for this term, then we get the same denominator, which then we can add together. We get n plus m equals m times n. So that means that we can then use this equation and know that this is 20. If we multiply both sides by 24 and divide by 5, and then move mn to the other side, we can get this equation, 20 times 24 divided by 5 equals m times n. And then we get 69 equals m times n. 18. In a diagram, ABCDEFGH is a cube with edge length of 12 centimeters. An ant sits on the cube at vertex A, which is right here. The ant can only walk along edges of the cube and cannot walk along any edge more than once. What is the greatest distance that the ant can walk before it cannot continue? This question is kind of just by intuition. The way that you just solve it is if the ant goes around the base and then goes top and then goes around the top again, it is stuck here. However, it goes along 9 edges, which is the most that it can walk. So it's 9 times 12 because each edge is 12 centimeters, and we get 108 centimeters. Question 19. We get this entire, a bunch of numbers adding together, and the question is asking, what is this equal to? Well, we see that, let's say, for example, we take 1 over 2. We see that 1 is 2 to the power of 0, and we said 2 is 2 to the power of 1. So what we know here is that if we take exponent rules, we know that if an exponent is divided by another exponent, then we can just subtract the exponents together. So 2 to the power of 0 divided by 2 to the power of 1 is equal to 2 to the power of 0 minus 1, which is 2 to the power of negative 1. And we see that this is the same for all of these other ones, because let's say, for example, 2003, 2 to the power of 2003 divided by 2 to the power of 2004, then it's still just 2 to the power of negative 1. We said 2 to the power of negative 1 is just a half. And since we have 2004 terms, because it's 2 to the power of 1, 2 to the power of 2, etc., to 2 to the power of 2004, then we have a half times 2004, which we get 1,002.